Hello students, I am Dr. Atanu Jana, Professor and Head Department of Dairy Technology, Shet MC College of Dairy Science, Anand Agriculture University, Anand. Today I will be dwelling on paper number 7, that is Technology of Milk and Milk Products, in which I will be discussing module number 10, Technology of Ghee Making by Direct Method, Direct Cream Method, Creamery Butter Method and Continuous Ghee Making Techniques. Ghee is one of a very important and costly dairy product. The most costliest component of milk is the milk fat, and hence the price of ghee will be accordingly priced. Any surplus fat you are getting in your dairy plant, because cream separation is an integral unit operation in a dairy plant. In flush season, we tend to get more milk in our dairy than probably we can handle. During such season, whatever surplus fat we have got, we can very well utilize them because they are storable. They can be stored at ambient temperature. So during surplus season, we can store the surplus fat, and during the lean season, we will tend to use it whenever need arises. Ghee also plays a very important role in our diet, not only for conferring energy. You know, fat gives 9 kilocalorie per gram of fat ingested, but it has got a special role. For example, some sweetmeats, for example, jalebis, etc., prepared, or gulab jamun prepared in ghee, fresh ghee. Some sweetmeats, other prepared in fresh ghee. They have definitely got a special attraction from the consumers. Now, there are several methods which affects not only its yield but even its chemical composition and the shelf life of the ghee. So, in this particular module number 10, we'll be seeing several methods of ghee making, namely number 1, ghee making by indigenous method, which can be adopted by the cottage scale. Second, ghee by direct cream heating method, wherein you don't need to go for butter making, that is white butter, and hence it is simplified, and finally you can prepare ghee out of it. The third and the most popular method is ghee making by creamery butter method, wherein you will definitely have to go for churning of the cream to get white butter as an intermediary product, which you'll be converting into ghee. And finally, the continuous ghee making, wherein each step of any unit operations will be short enough so that directly from cream as a starting material we can get a ghee similar to what you have already seen maybe for continuous butter making from cream to butter. Likewise, in this case you will be getting from cream to ghee. Now the ghee has got a wonderful shelf life at ambient temperature. You did not go for refrigeration as you require for milk or other milk products like sweetmeats. And of course, ghee can also undergo certain spoilage during its storage. So if under technology background, if you know how to prepare ghee under a condition where its oxidative spoilage can be minimized, such techniques if we adopt, you will have extended shelf life ghee till the use by date you have given on the label. I am dealing with the specifications laid down for ghee in Gujarat state. The first is moisture, that is a maximum moisture content, that is 0.5% maximum. But let me tell you that as per EGMARC specifications, which is not compulsory, it is maximum 0.3% moisture, whereas in FSSA they allowed slightly higher, that is 0.5% maximum. If you see in this particular slide, I have written there are two types of specifications laid down for ghee in Gujarat state. One is for a cotton tract and another is for a non-cotton tract area. Now, what is the meaning of this cotton tract and why they have bifurcated or classified into these two norms? The feed of the animal, particularly in a cotton tract area where people are going to take out the cottonseed oil and give the cake, cottonseed cake, as a feed to the animal in that region. The fatty acid profile of the cottonseed oil, little bit what is coming with the cake, influences the fatty acid composition of the milk produced. When you are preparing ghee out of such milk, the certain fat constants, we'll see later on, the BR reading, RM value, these can change based on the feed intake of the fatty acids. And hence, the specifications legal have been bifurcated into cotton tract and non-cotton tract area. However, there will be slight variations between the two. For butyrorefractometer reading at fixed temperature of ghee should be 40 degrees centigrade during its analysis. In short, it is called BR reading based on refraction of the light when it passes through a melted ghee. For cotton tract region, it should be between 41.5 to 45, whereas in non-cotton tract, it ranges between 40 to 43.5. What is the significance of this BR reading? In case you are getting some sample of ghee and analyzing it for BR, it is coming less than the minimum of cotton tract, for example 39.0. This indicates there may be some chances of some adulteration to the ghee, because of which the constant which it is showing is abnormal. So this helps in assuring the consumer what really is being paid for a correct product. The next fat constant is Richard-Meisel value, in short known as RM value. It should be minimum 21 for a cotton tract area and minimum 24 for non-cotton tract area. Again, as I told you, for BR reading, any values below such minimum value may be indicative of some adulteration taking place in the ghee, which probably you are getting it tested for. Third, a very paramount importance, and that is free fatty acids. I have abbreviated here as FFA. It is expressed as percent oleic acid, and the maximum limit given, irrespective of the cotton or the non-cotton tract, it is maximum 3. However, let me tell you, for Egmark specifications, they have bifurcated into 3 different classes of grades of ghee, namely special, standard and general grade ghee, only based on the free fatty acid content. Obviously, lower the FFA content, greater or better would be the grade of that ghee. However, as per FSSA, there is no bifurcation related to the grades of the ghee. The last test shows you the Bowdoin test, and which should be for all India, not only for cotton or non-cotton or any state of India. It should show negative, and negative means the ghee, whatever you are testing for, has not been adulterated with hydrogenated vegetable fat, which commonly we refer to it as vanaspati or dalda. So it is made out of only vegetable oils and fats. They are hydrogenated to have higher melting point, the dalda I am speaking of. So in case anybody is using that to adulterate ghee, if Bowden test shows positive, that is red color, after the test is carried out, in that case such ghee is adulterated not with any other vegetable oil, but specifically hydrogenated vegetable oil. The next slide, which indicates the microbial specifications for ghee as per our legal FSSA standards. If you see the standard plate count, it should be maximum 5000 per gram as colony forming units, CFU per gram. If you recall the SPC of pasteurized milk, for the same FSSA, it is maximum 30,000 per ml. Now, but remember here, the moisture content is very less than 0.5. Even bacteria needs water to thrive in such environment, and hence you can see such a small CFU per gram of limiting 5000 per gram. The second, coliform, and under coliform category you have Escherichia coli. In case you are getting this in your enumeration count, this indicates unhygienic practices carried out during ghee, not only manufacture but handling and storage or packaging also as contamination. So remember, this should be always absent in 1 gram, be it coliform or be it Escherichia coli. The second one is yeast and mold count, which should be again absent in 1 gram. Supposing you are getting a yeast and mold count, it indicates contamination from the surroundings from where your ghee is prepared or packaged. So again, take strict hygienic practices so that you get absent in 1 gram in terms of yeast and mold. Anaerobic spore count. Why spore count has been indicated? Ghee is prepared at a temperature of clarification, heat clarification around 111 to 118 degrees centigrade for few minutes. At such a high temperature, you can't expect the vegetative bacteria to survive. Even the spore forming bacteria, which are highly heat resistant, they tend to be destroyed, and hence they have given the anaerobic spore count in ghee. Even whenever we are packaging ghee in, say, tin, maybe 1 kg tin or maybe 15 kg bulk tin, the amount of headspace is very less, and hence the amount of oxygen is low, and you have literally little of anaerobic conditions, and hence they have given the anaerobic spore count, which should be again absent in 1 gram. The Salmonella, Shigella, both pathogenic bacteria, obviously has to be absent in 25 grams. Other two pathogens, namely Staphylococcus aureus and Listeria monocytogenes, both of them have to be absent in 1 gram. So it is obvious that any pathogenic bacteria which can come as a post contamination after processing should never be there in any of the product to be sold and marketed. Now we go on to the grades of ghee as per EGMAR. And I was referring, whenever I was taking the FSSA requirements for ghee, I was referring to the EGMAR, agricultural marking. Now remember, FSSA is compulsory for any manufacturer when he is selling that in Indian market. However, EGMAR, though not compulsory, you will find in most of the products, including honey, including dhania powder or turmeric, you will see this EGMAR seal on that. Now this indicates the purity, no adulteration in that, and consumer is well aware of such mark or seal on the pack. As I had indicated earlier, there are 3 different grades of ghee, namely special, general and standard. In all of them, irrespective of the grade, the moisture content should be maximum 0.3%. That means the fat content would be 99.7% minimum. Bowden test, as I told you, for FSSA, obviously no adulteration with any dalda or hydrogenated vegetable oil can be tolerated by anybody. So it should be, the Bowden test shows negative. However, in terms of free fatty acids expressed as percent oleic acid, lower the FFA content, greater is the quality, that is the raw material which you have used in ghee making, and you can expect greater shelf life when you are storing such product for a span of, say, 1 year at ambient temperature. So special grade EGMA ghee should have maximum, that is less than 1.4% free fatty acids, and as you go on higher, that is maximum 2.5, it becomes a general grade, still higher up to maximum 3% FFA, rather, which is the standard for FSSA for in general, and there are no grades in FSSA. In that case, as per EGMA, they give it as a standard grade EGMA ghee. So lower the FFA, greater would be the shelf life you expect out of that particular ghee, and accordingly special grade has been christened by EGMA for certification. Let us see the technology, the different methodologies which we can adopt at our industrial level in order to prepare ghee. The first one written in the slide, that is the indigenous method using makhan as an intermediate raw material or semi-finished material. This is not practiced by industrial method. However, at home or at cottage scale, you may definitely do it. And the taste of this particular ghee would be the best. You'll be having the diacetyl flavor as well. Some flavor components as a result of fermentation, which is one of the essential process in preparation of dahi and makhan. However, in large scale, there is no indigenous method that is practiced. The second onwards, this are definitely used industrially. The second one is direct cream heating method, wherein you will be directly starting with cream. But if you have a higher fat of the cream, even by reseparation of the already separated cream, for example, generally whenever we separate cream, the fat content will be something around 35 or 40% fat. If you reseparate the cream, you may get 65-70% fat. And if you start with such high fat cream, your energy saving will be there, and even the amount of ghee residue formed from the SNF will be low, and you will be getting very good fat recovery in ghee made by direct cream heating method. Here, there is no need to prepare any intermediary white butter. Okay, so any associated equipment and handling you require for butter making is not required here. Very simple process. The third method, very widely adopted all over India, is the creamery butter method. In this case, the starting material, rather the semi-finished material, should be the white butter. You already know that white butter contains around up to maximum 16% water. It also does contain some curd content, which we call as SNF content. All you have to do is remove the moisture to less than 0.5 or 0.3% as per FSSA or EGMARK standards by heat treatment, that is using steam under pressure. And finally you get a ghee, and of course you will be getting ghee residue, which we will have to remove it, clarify it off separately from the ghee. So this method is widely adopted, and the fat recovery obtained by this method is quite good compared to the one made by direct cream method. So it is a better method and widely adopted. The third one is a little modification to the previous, that is creamery butter with pre-stratification. In this technique, the main objective is to reduce the energy consumption in terms of steam and the electricity. Whatever moisture content you have got in white butter, if you can give some time to separate from the melted butter at 80 degrees centigrade, you will have three different strata of scum, fat and serum. Now this serum portion contains majority of the water. If you can drain it just by removing such by decantation or removal from the tap at the bottom, valve from the bottom of the tank, you have got less than 1% of the serum or water content to be evaporated to less than 0.3%. So here there is lot of saving in the energy. The amount of ghee residue formed will be less, since even lot of SNF goes away with that serum when you are removing it, and hence again the recovery of fat in ghee is very enormous. The last one is continuous ghee making, wherein each unit processing you do it in ghee manufacture. For example, preparation of butter, then melting of butter, then separation of water from the or serum from the butter. Each phase has to be immediate so that a final continuous ghee making is made feasible. So in practice, even in India, you can see such continuous ghee making processes at several places like Amul Milk Fat Gandhinagar, at Nestle, at Moga Punjab, etc. This is the one I am showing you, the creamery butter method of ghee making adopting pre-stratification. regarding which I have already given you the principle behind the same. The starting material is a fresh cream with 40% fat and less than 0.1% lactic acid. Ripening using lactic acid bacteria of the cream is optional. Why optional? Especially since if you go for ripening, the acidity, the cream is going to be a little sour, and in the later whatever ghee you produce, the FFA content will be slightly higher. So supposing you were aspiring to prepare a special grade ghee, you will not be able to get it by using a ripened cream product. However, if you ripen it, the flavor of the resultant ghee as you get it from makhan will be very, very, very delicious. Next step would be, after aging of the cream and pasteurization, of course, pasteurization and aging, churning of the cream in butter churn, be it batch or continuous butter maker. You'll be removing and collecting the buttermilk and you'll be obtaining the white butter, which is the intermediate in preparation of ghee. This white butter would contain minimum 80% fat, rather it would have around 82% fat. Curd content will be less than 1%, and there is no salt at all in this, remember. This white butter is subjected to melting by raising the temperature using steam or any other heating media to greater than 80 degree or around 80, and then this melted butter is pumped into a stainless steel tank similar to your milk silos and allowed to stay there undisturbed for a period of about 1.5 to 2 hours, wherein you will have pre-stratification into 3 different layers. The bottom one will be the serum or the aqueous phase, which you are supposed to drain it by gravity. Now, other 2 layers inside the tank, that is the fat, majority of the layer, and the scum at the top, both of them are to be pumped into a ghee kettle, wherein the heating will be there with steam under pressure. The fat phase is heated to 112 to 115 degrees centigrade and held if required to a moisture content less than 0.3% for egma. The next step would be filtering and clarifying out the ghee residue which is formed simultaneously as a result of heat treatment, and they are basically the SNF in a dried form devoid of the moisture. This ghee is now to be packaged in desired size containers at a particular volume size or by weight. This package can be either tins or even laminated. Flexible pouches can be used of a given thickness, say 100 microns of HDPE, high density polyethylene. Remember that the temperature of the ghee should be around 40 to 42 degrees centigrade so that they remain in a liquid condition when you are going to fill it inside the container, individual container. The next optional step I have shown is seeding. Actually, granulation of ghee or the granule formation in ghee, it is because of the crystallization of the fat present in ghee itself. But there may be certain conditions wherein, because of the feed, because of the season, only during few months, maybe in a ghee, you did not get as much granulation which a consumer would desire for. In such case, you may go for addition of some pre-granulated ghee, your own ghee, because ghee has got a shelf life of 1 year. Now you have got your previous month, say 5 months old ghee, which has been already granular. So half a spoon of such granulated ghee, adding it in 1 kg of tin filled with the ghee, but at a temperature at 27 degree or below degree centigrade. You add that half a spoon, mix it, seal it, and then keep it at a temperature around 25 degree or 24 degrees centigrade for few hours, and then transfer all these sealed tins to room temperature. Whenever the consumer will be opening this tin, they will find granulated ghee coming out as a result of such seeding if needed. And finally, as you know, ghee has very less water content. Because of such high temperature of 115 degree, there is hardly any bacterial spoilage, and hence you can store it at room temperature and it can stay for 9 to 12 months very easily. Slide depicts the chemical properties of ghee as affected by the clarification temperature. As I told you, a wide variation in the heat clarification temperature is taken or adopted by a ghee maker. If you go for a higher clarification temperature, there will be development of higher cooked flavor development in the resultant ghee. Some consumers, for example, they say South Indians, they prefer more cooked ghee, whereas North Indians, they do not prefer cooked ghee. So based on that and the shelf life, higher the temperature, higher will be the shelf life of the resultant ghee. So I have given you instance of say 110 degree as clarification temperature, and a heating period at that temperature it has been kept for 10 to 15 minutes. In the next two rows at 120 degrees centigrade for 5 or 10 minutes holding period, you can see the moisture content in above 110 degree it was 0.14 or 0.12% moisture, whereas if you go for higher temperature 120, that is 10 degree more, the moisture content is reduced up to 0.09%. So higher the temperature, lower will be the moisture content. The FFA content, if you see, it is exactly opposite trend of moisture. At higher temperature, that is 120 degree, the FFA content is higher in terms of percent oleic acid, 0.33 to 0.35 versus just 0.23 to 0.24 when you are adopting lower temperature of 110 degree centigrade. If you see the oxidative stability in terms of hours, now let me tell you, higher value in hours is desirable. So you can see at higher temperature, 120 degree clarification temperature, the oxidative stability is higher. You can see the value ranging from 24 to 26 hours as against only 15 to 19 hours when you are keeping a lower 10 degree centigrade, that is 110 degree Celsius. So the clarification temperature does have some impact on the shelf life as well as the chemical composition of the resultant ghee. This table shows you the comparison of ghee with anhydrous milk fat and butter oil. Now let me tell you what is this anhydrous milk fat and butter oil. You must have heard about recombined milk, where to the water we add number one a fat source which can be AMF, that is anhydrous milk fat, and you also need a SNF source such as skim milk powder. When you recombine the entire thing, homogenize, pasteurize, you get a product called recombined milk. AMF is such kind of fat source which can be preserved at ambient conditions for extended period and can be used as a fat source in any food product you want to prepare. Now AMF has got a composition very similar to that of ghee. However, both are different, their end uses are different, and even India used to import anhydrous milk fat or butter oil from countries abroad during our Operation Flood program given by the National Dairy Development Board, Anand, Gujarat. Let us see the difference between ghee and AMF. The parameters I have shown is number one, the fat. Ghee has got lower fat content than either AMF or butter oil. Between AMF and butter oil, let me tell you, AMF is something which is produced from a superior quality raw material, whereas butter oil is a product which can be prepared from a raw material, which could be of certain age. Age means it could have been stored for certain time. For example, white butter has been stored for a period of 5 months and then it has been made into AMF. Whereas to prepare AMF, you will have to directly start using a freshly prepared white butter to be converted into AMF. The second is the moisture content. The ghee as well as butter oil can have a maximum moisture of 0.5, whereas AMF, even Indian standard is there for FSSA, which specifies a maximum of 0.1% moisture. That means the moisture content in AMF is much lower than that in ghee. The free fatty acid content are very important, since you already knew that FFA content can decide even the grade of the ghee for Agmark grade. The FSSA has given maximum 3% oleic acid for ghee, whereas AMF, it is not a standard but has got FFA of less than 0.3. So you can imagine the raw material quality which has been used in preparing AMF, that you are getting such a value of FFA which is much superior than even the special grade Agmark ghee. The fat-free dry basis is some similar to your ghee residue. That is, other than fat, any dry matter, very, very less amount of ghee residue like thing, 0.2 to 0.4. Whereas the last column, peroxide value, is very important. If the peroxide value is high, the shelf life expected out of such product will be low when stored under ambient conditions. So if you compare AMF and butter oil, AMF has got a lower peroxide value of 0.2. That means it can have a better shelf life compared to butter oil, which has got a higher peroxide value of 0.8. Coming on to slide, fat recovery of ghee made by different method. Now we have seen several methods of ghee making. Each one of them have their own drawbacks or even advantages over other methods. However, fat is certain costliest component of milk. Higher the fat content in any product, for example ice cream, even the variant of milk, higher will be the price of such product containing higher fat. So whenever we are preparing ghee, the recovery of ghee compared to whatever intake of the kg fat we had taken in our creamery or dairy factory is very important. Now let us see the three different methods I have given here. One is indigenous method, which is seldom adopted in the commercial level. However, the second two, that is creamery butter and direct cream method, they are definitely used, particularly the second one, creamery butter, is very widely adopted. Let us see the fat recovery it gives and why so. If you see the indigenous, it gives a fat recovery of only 82%. That means around 18% fat loss we have got, 18% fat loss in the first category. In creamery butter, we are getting around 92% fat recovery. That means we are losing only 8% out of 100. So we are getting the maximum fat recovery here, followed by direct cream heating method of ghee, wherein you are getting around 88% fat recovery, which means you are losing around 12. So compared to creamery butter, the losses in direct cream as well as in indigenous method of ghee making, you are having more fat losses. Now let us analyze why there is more fat losses in these two cases. If you see the indigenous one, the buttermilk during churning of the curd, fermented curd, into makhan, the buttermilk that is formed, there is a higher fat loss because of the crude indigenous technique used of churning. So you have got 13% fat loss over there. The ghee residue quantity is also quite good because makhan contains quite good amount of SNF. So you can see the ghee residue fat is 1.87. Handling losses also are quite good. That is around to the quantum of 2.5, and hence you are finally getting a fat recovery of 82. Let us go into the second category, creamery butter method of ghee making. Skim milk, whenever you are separating milk into cream and skim milk, in skim milk you are losing around 1.4. Buttermilk, under very close standardized conditions, 40% fat cream, aged well, and then you are churning it, the fat loss in buttermilk is less. So you are getting only 0.85 compared to 13% fat loss with the indigenous churning of dahi into makhan. Ghee residue will be even lower than in case of makhan. So again, the ghee residue fat loss is less, 1.45. Handling losses are more because you have associated aging, churning, etc. So 4.5 is your fat loss during handling. So finally, you're getting around 92% fat recovery, which is the best when compared with these among these three methods. The third one, direct cream. Remember, we are not going to churn cream into butter, and hence in buttermilk I have shown a dash, that is nil fat loss. Skim milk, definitely you'll be having 1.4 as in previous case. Ghee residue, the SNF content in cream is greater than the SNF content of butter. So in the resultant ghee prepared from cream, the amount of ghee residue form will be more, so higher will be the fat loss, and here it is shown as 9. Handling losses will be less because the associated butter making is absent. So it is only 1.7. So finally you are getting 88% fat recovery, but which is again lower than that of creamery butter. So that is the reason why throughout India you will find majority of the commercial butter makers are adopting creamery butter method, which gives the highest fat recovery. Coming to the yield of ghee as made by different methods, as well as the phospholipid content of the ghee residue if you are adopting different methods. Yield is very important. As I told, the higher the losses of fat, wherever it is lost, you will have a lower yield, and greater the fat recovery, you will have a higher yield. So if you correlate your previous ninth slide of recovery with this slide, you can see with direct cream method, the yield has been highest 12% because probably a higher fat cream was taken here for ghee making. For creamery butter, we know we take around white butter with 80 to 82% fat. The yield is 3.7. Whereas in desi ghee, since the moisture content is more in such ghee, the yield is higher, that is 4.3%. The next category we are going to discuss for ghee is the phospholipid content. Phospholipids are natural substances present in the milk fat, particularly in the milk fat globule membrane, which can exert some antioxidant effect. Milk fat is prone to oxidation, especially during a prolonged storage. Higher content of phospholipid in the ghee, be it natural or added externally, will help in preventing auto-oxidative deterioration, and automatically the shelf life of the ghee will be extended or enhanced. So if you compare the direct cream heating method and creamery butter method, in the ghee residue, the phospholipid content is greater in ghee residue obtained from creamery butter, that is 2.7 to 7.9%, whereas in the ghee residue obtained with direct cream method, the phospholipid content is 0.86 to 1.5. Remember, the application of such thing means, supposing you add this ghee residue into the subsequent lots of ghee you are preparing, which are not potent in natural antioxidative material. After heat treatment, remove the ghee residue which you added, you will find the ghee has got extended shelf life at ambient temperature. Such is the importance of such natural antioxidative substances such as phospholipids in ghee, and they are definitely affected by the method of ghee making. For this module number 10, the different methods of ghee making, we have already seen the 5 different methods, namely the indigenous method of ghee making, second using direct cream heating, third using creamery butter method, fourth one is the improvised method of the third one, that is creamery butter using pre-stratification technique, and the final and the most latest and probably automated is continuous ghee making technique. All of these techniques, if you see, has their own advantages and drawbacks. If you see the advantage of ghee making by creamery butter method, the recovery of fat in the ghee will be the highest. If you see the advantage of direct cream heating method, the ghee obtained by such technique has got the highest shelf life at ambient temperature, because the extent of period of heating, because cream would contain greater water content than the butter, which contains less than 16% water. So the time required for obtaining ghee from a unit quantity of cream will be greater, giving extended shelf life to the ghee, since the phospholipid content coming in the ghee will be greater. Phospholipid is a natural antioxidative substance present naturally in the milk. So, if we know the various methods of ghee making, the fat recovery associated with them, and the shelf life and even the quality in terms of granularity of the ghee, in that case, a ghee maker can choose from amongst various methods which he should adopt under the conditions he is preparing, so that he can sell his ghee with a good margin, at the same time giving good quality to his consumers. Thank you.